Hi guys, this video is just to help you with this homework. If you are having any trouble with it, this will go over it. So there are two basic theorems that there's a focus on, and that's the tangent chord theorem and the tangent radius theorem. And the tangent chord, it's half the arc intercepted, and the tangent radius theorem is that it's making a 90-degree angle. The tangent chord is kind of like the inscribed, is similar to inscribed. So I'm just going to make a note of that. It's similar to inscribed angle theorem. Similar to inscribed angle theorem. Okay? And that's that. So that's that information. Now let's get on to working with it. So here they're asking you about this little angle here. So this little angle, if you can see that, is being formed by a tangent line, which means it touches the circle once, and a chord. And the arc that it is focusing, that it's intercepting, is this, which is in the mouth. The arc is what's in the mouth of this angle. That angle is, that arc angle degrees is 130. So the tangent chord theorem is saying that the angle is 1/2 of that arc intercepted. So that angle KLM, that's KLM because L is in the point and it's on the circle, is equal to 1/2 of 130. And that's an arc, so I put a little arc symbol of it. So angle KLM is 65 degrees. And that's that. Okay, now let's look at this next one. This next one is not talking about the arc that it opens up to. It's really just seeing that this is a radius and this is the tangent, so this is 90 degrees, which makes perfect sense because if you were to extend this arc is 180 and half of it is 90. So just a good thing to notice. In any case, the focus here is, since this makes a right triangle, as you see, there's always the hypotenuse is opposite the right angle, and these are legs. So here's a leg, and here's a leg. Oops, that's a G, EG. So you can use Pythagorean theorem. That is a squared plus b squared equals the hypotenuse squared. So this is 12 squared plus 16 squared is equal to what we're looking for, x squared. So this is, add these two together, and that's 400. And that's equal to x squared, so x is equal to 20. So when they were asking about this piece, it's 20. All right, moving along. Over here, again, they're not really asking me about an arc. There's no arc really. They're just really talking about the sides of a triangle. So here's one side of a triangle. And we don't have a full other side, but since this is a radius, and this is a radius, then you know that this is also 6. So when you think about what that whole side is, you would be like, oh, that whole side is 12. So we have one side is 6.4, the other side is 12, and that will help us find the hypotenuse, which is the question mark. So that will be 12 squared plus 6.4 squared is equal to the hypotenuse squared. So that is, when you add these two pieces together, that's 184.96 is equal to h squared, or x, whatever you want to call it. So I square root both sides, and I get h is equal to 13.6. All right, thank you. And now we're going to look at this next one, number 4, and that's that one. Let me box that. And number 4, we're looking at this little question mark here, and this has to do with an arc. So this is an arc. So this is like one of those half of something, or I don't know. Well, that arc I can't really get to. It's not inside of anything. It's sort of strange. I don't see a tangent. All I see is, I'm going to focus on this angle right here. So in order to do anything with that angle, I have to extend the angle that is make like all the way open, and make a connection between where that ends all the way that arc that it's opening up to. So this, if you remember the name of it, this angle here, because it's on the circle, it's not a central angle, it's inscribed. So that is an inscribed angle. And because that is an inscribed angle, that means that the arc, that the angle is 1/2 of the arc that it intercepts. So that 95 is 1/2 of this RQ, that arc RQ. So if I want to get RQ by itself, I would just double the 95. And if you just double the 95, I believe that's 190. So this whole arc is 190. But that doesn't answer my question of what SQ is. So you have to make an additional connection. You have to make the connection, well this is 75, and now I know this is 190. How could you figure out the rest? And that's where, if you thought it and you figured it out, good for you. So if you thought, 75 plus 190 plus this missing piece has to add up to 360. If you were thinking something like that, you were right. So that would be 265. I think I added that right. It's 360. And if I subtract it, do I really get 95? All right, well that works. 95. So that was the answer for that one. Alrighty then. Last question. Woohoo. Okay, so this one, just pick a different color for that. It says they gave you this diameter, and then they said that AC and CB does this 1:4. That means they're in a ratio of 1:4. So that usually bugs people out, but they're really not that bad. What you want to do is when you read this, is you want to go to AC and make that 1x, and go to CB and make that 4x, and just label it that way. So go to AC, and that's the arc part, not an angle. So that's x. I'll just put x. And then this other part here, that's 4x. And we want a numerical value for it. So I know that they make a whole semicircle there. So I know that x plus 4x put together is 180 degrees, because it makes, I'll show you, it makes this whole 180. It's that diameter, so that's why it's 180 all around. That says 180. That's me trying to write a 180 for the whole piece going around, right? Up to here, up to the... Okay. So since that adds up to 180, that means 5x is 180. That means if I divide both sides by 5, I get 36, I believe. So that means this little guy here is 36 degrees. And the other one, 4x, is 36 times 4, which ends up being 144. 144 degrees. And they asked me, ultimately, the question is, what is the measure of angle EBC? EBC, this angle. That is tangent chord. Oh, that's an H. So that tangent chord theorem, I know that the angle inside here that they're asking me about, that angle EBC, is equal to 1/2 of the arc intercepted, of the arc that's intercepted. So that's 1/2 of what's inside the mouth of that angle, and that is 144. So the angle that they're asking, angle EBC, is 72 degrees. Okay. I hope this helps, and that you have getting an understanding of this circle theorems. Have a good day. Bye bye.